Good afternoon, ladies and gentlemen. Today I want to present about the effect of UA injectors to optimize the NOx conversion in SCR systems. My name is Aditya Wardana, Kwangchul Oh and Ocktaeck Lim present today. This is the outline we want to present today. First, the introductions, methodology, research and discussion, and conclusion. In here, we open deeply about the effect of UA injector to the SCR system performance. Why the SCR systems? As you know, the automotive industry has been restricted by several regulations to reduce nitrous oxide emission from diesel engine and heavy-duty diesel engines. And selective catalytic reductions with the ammonia is the most promising solution to control NOx from diesel engine and heavy-duty diesel engines. This is the advantage and the disadvantage of SCR system. First, this is higher NOx reduction yield and simple to install. Even with current situation, we doesn't have the SCR, but we can easily to install SCR system in that systems. The advantage of the SCR systems is has large size of particle urea and difficult to evaporate with the current temperature of SCR systems. Urea deposit attached in the wall and easily to become solid deposit. Ammonia and nitric oxide difficult to mix in the systems. And the cost of the catalyst is quite expensive. Hendrik Schmidt in 2014 explained about the solid deposit in his systems. The solid deposit easily to attach in the system and become grow. As you know, as you can see in the figure that this is in the wall. So the growth of solid deposit is increase by period of times, and also urea easily to become solid in the catalyst and then easily become solid also in the urea injector. So why we explain deeply about the urea injector? Because of this reference also. The objective of this study, we want to understanding the effect of two different types of urea injectors. In here, we will do using two different type of injectors. First, the L-type injector and I-type injector. And then we want to understand about the velocity and temperature gas distribution in the SCR systems. And after that, we will identify the NOx quality in the SCR systems. And also we will show you about the ammonia uniformity in the catalyst inlet. In here, we will use the 1000 RPM engines of operation systems. The methodology of the system is we using the 12cc diesel engines with the 6-cylinder and 4-cycle diesel engine. And then we using 1000 RPM engine speed conditions. In here also we using the two type of different urea injector, but the specification is similar. They has a 3-hole spray urea, and then with hole diameter is 120 micrometer. This is the engine specification we use. In here we using the Hyundai D6cc with the best torque in 1000 and to the 1.5 thousand RPM. However, in here we only do in 1000 RPM to show you the performance of the SCR system with the urea injectors. This is the specification of that engines. As I explained it before, that we using the simulations and also the experiments. The simulation we do, we using the Star CCM Plus version 12.4, and then to apply the CFD in the system, we base the experiments. So the specification of simulation experiment similar, even the size, the distribution from the inlet also similar. This is the position of the system. Press the injector, inlet, the outlet, the SCR catalyst, and DPF catalyst. This is the deposit formation in that system. As you know, when the urea inject to the systems, there has the spray particle. The spray particle here will break out or become the smaller particle after they hit the wall. And the smaller particle easily to evaporate by the temperature from the engines. However, someday the urea easily to attach in the systems and become solid deposit. This is the main problem in SVR systems. More higher the urea attached in the systems are also more grow the solid deposit formation in that system. So by using the different urea injector, we want to show you how we can reduce these problems. This is the experiment we do in this research. This is the D6cc diesel engine with 12,000 cc, and then this is the SUR systems. In here, we're using the gas analyzer to explain you, to show you also about the ammonia distribution in the catalyst inlet. This is the catalyst inlet we're using. This is the urea injector we use. In here, we're using the L-type. L-type is the current urea injector, and our suggest is we're using the I-type injectors. Result and discussions in part. So this is the temperature phenomena in SCR system by using the L-type and I-type. In here, we can show you that the temperature is quite similar. If you saw in the figure, it means the more better in I-type for the distribution rates. However, we not conclude this part. However, we conclude in this part. So the inlet catalyst, so the inlet in here is quite similar. However, if we show you the I-type is more higher because the quantity of ammonia distribution in the system is more higher than L-types. Also in this part in saturation phenomena in SCR system by the L-type urea injector and I-type urea injector, we can show you that almost similar like the temperature, that more higher in I-type quantity for ammonia in I-type. However, if we show you this, the L-type is more good for spread the ammonia in that system. The saturation phenomena for L-type and I-type also similar, that quantity of ammonia in I-type is more higher than L-types. So this is the sampling of ammonia value by using this sensor that we can see here that the quantity of ammonia more better using the I-type than L-type. But this is a short period, but if we using the long-term period, I think more better in I-type. But we cannot show you now, but we will do in the next or future research for compare the I-type and L-type with the long period in here. Why we understand that? Because the L-type is the position of spread in the middle of pipe, and then the I-type in the top of pipe. So it's mean the L-type is more easily to evac by the temperature. So the quantity of ammonia we estimate that will be not stable in here. Even the distribution of the ammonia is more better than L-type. However, for the quantity, I think more better in I-type. And then in this result also say similar, like we suggest that I-type more produce the higher ammonia than L-type. As you know here, the figure we can see here that L-type position in the middle of the pipe, however for I-type in the top of the pipe. So it's mean this is more easily to effect by the temperature from the engines than I-type. This is the ammonia uniformity in the inlet catalyst. By the experiment and the simulation, we can sense that the performance of ammonia uniformity is better in L-type because the distribution is more uniform than I-type. However, even the I-type performance not so good like the L-type. However, the I-type more produce higher ammonia than L-type. So if we put some mixer in the system or increase the mixer or flow in the system, I think more better the uniformity of I-type. So we're doing this in the next research. This is the result we get that L-type has the solidification in the inside of the injector. So why the quantity of L-type not so high or not similar like I-type, because it's these problems. So the solid deposit formation by urea is hampered the distribution of urea in the L-type injector. So the quantity of urea in here is reduced because of these problems. So the ammonia quantity also similar because the distribution is hampered, and then they also will increase day by day. If we using the long period, maybe this is more increase like that. So, however, we now is using the short period, but the future we will deeply open these problems. So the Knox conversions of L-type and I-type, even the L-type is good uniformity, but as you know, the I-type has the higher uniformity than L-type. So the Knox conversion for I-type is more better than L-type if we doing the average here. So maybe if we increase the mixer or flow in the system, maybe the result is also different. I think more better in I-type. So maybe in the future we using or we increase the mixer in here, so we can understanding the differences I-type without I-type with the low mixer and with the higher mixer, more better the ammonia uniformity, and also maybe the NOx conversion also more better. So the conclusion of this research, the I-type and L-type had a very uniform pattern of gas distributions, but the ammonia gas ratio from I-type better than L-type in the systems. The I-type urea injector produces higher quality of your decomposition process than L-type urea injector, and reduce the occurrence of possibility of your solid deposit process in the system. However, the L-type urea injector produces higher value of ammonia uniformity pattern in the experiment with 19 sensor than I-type urea injector. But in the future, if we doing the I-type urea injector with the increasing the mixer process, I think more better the uniform of I-type. This is announcements. We will thank you from the Korea Environment Industry and Technology Institute for support us to doing this research. Thank you very much.